You need to compare the costs of running an application in an on-premises data center with the costs of running the application in Azure. What should you use to assist you? The TCO calculator helps you estimate the cost savings over time of operating a solution in Azure compared to operating in an on-premises data center. You need to associate the costs of resources to different groups within an organization without changing the location of the resources. Your organization plans to deploy several production virtual machines that will have consistent resource usage throughout the year. What can you use to minimize the costs of the virtual machines without reducing the functionality of the virtual machines? What can you use to ensure that new and existing Azure resources stay in compliance with corporate standards? You need to recommend a solution for Azure virtual machine deployments. The solution must enforce company standards on the virtual machines. What should you include in the recommendation? What allows you to orchestrate the deployment of resource templates, Azure policy assignments, and resource groups? What allows you to orchestrate the deployment of resource templates, Azure policy assignments, and resource groups? Azure Blueprint simplifies large-scale Azure deployments by packaging key environment artifacts, such as Azure Resource Manager, ARM, templates, role-based access controls, ABAC, and policies, into a single blueprint definition. You can easily apply the blueprint to new subscriptions and environments. What can you use to restrict the deployment of a virtual machine to a specific location? What can you use to restrict the deployment of a virtual machine to a specific location? Which two actions can be performed by using the Graphical User Interface, GUI, in the Azure portal? Each correct answer presents a complete solution. What can you use to define the resources you want to provision in a declarative JSON format? What can you use to define the resources you want to provision in a declarative JSON format? which management layer accepts requests from any Azure tool or API and enables you to create, update, and delete resources in an Azure account. What can you use to create resources in Azure and includes a validation step to ensure all resources are created in a specific order based on dependencies, in parallel and idempotent. Which two tools can you use to create a new Azure virtual machine from a mobile device that runs Android? Each correct answer presents complete solution. What can you use to manage servers across cloud platforms and on-premises environments? What can you use to manage servers across cloud platforms and on-premises environments? What provides recommendations to reduce the cost of Azure resources? Which Azure service evaluates Azure resources and makes recommendations to help improve reliability, security, performance, and cost reduction? You need to be notified when there are new recommendations for reducing Azure costs. Which tool should you use? What can you use to automatically detect performance anomalies for web apps? Select the answer that correctly completes the sentence. Answer choice is the logical container used to combine and organize Azure resources. Select the answer that correctly completes the sentence. Answer choice are physically separate data centers within an Azure region. Which two components are created in an Azure subscription? Each correct answer presents a complete solution. Which resource can you use to manage access, policies, and compliance across multiple subscriptions? Which resource can you use to manage access, policies, and compliance across multiple subscriptions? What can you use to execute code in a serverless environment? What can you use to execute code in a serverless environment? Azure Functions allows you to run code as a service without having to manage the underlying platform or infrastructure. Azure Logic Apps is similar to Azure Functions, but uses predefined workflows instead of developing your own code. You need to allow resources on two different Azure virtual networks to communicate with each other. What should you configure? You need to allow resources on two different Azure virtual networks to communicate with each other. What should you configure? Which two services can you use to establish network connectivity between an on-premises network and Azure resources? Each correct answer presents a complete solution. What can you use to provide Mac and Android users with access to a Windows environment that will run Windows-based applications? Azure Virtual Desktop is a desktop and application virtualization service that runs in the cloud. It enables your users to use a cloud-hosted version of Windows from any location. Azure Virtual Desktop works across devices such as Windows, Mac, iOS, Android, and Linux. It works with apps that you can use to access remote desktops and apps. You can also use most modern browsers to access Azure Virtual Desktop hosted experiences. What are two services that allow you to run applications in containers? Each correct answer presents a complete solution. Which Azure Blob Storage tier stores data offline and offers the lowest storage costs and the highest costs to access data? The archive storage tier stores data offline and offers the lowest storage costs, but also the highest costs to rehydrate and access data. The hot storage tier is optimized for storing data that is accessed frequently. Data in the cool access tier can tolerate slightly lower availability, but still requires high durability, retrieval latency, and throughput characteristics similar to hot data. Which storage service offers fully managed file shares in the cloud that are accessible by using Server Message Block (SMB) protocol? Azure Files offers fully managed file shares in the cloud with shares that are accessible by using Server Message Block (SMB) protocol. Mounting Azure file shares is just like connecting to shares on a local network. Which two scenarios are common use cases for Azure Blob Storage? Each correct answer presents a complete solution. Low storage costs and unlimited file formats make blob storage a good location to store backups and archives. Blob storage can be reached from anywhere by using an internet connection. Azure Disk Storage provides disks for Azure virtual machines. Azure Files supports mounting file storage shares. Which Azure Blob Storage Service tier has the highest storage costs and the fastest access times for reading and writing data? The hot tier is optimized for storing data that is accessed frequently. The cool access tier has a slightly lower availability SLA and higher access costs compared to hot data, which are acceptable trade-offs for lower storage costs. Archive storage stores data offline and offers the lowest storage costs, but also the highest costs to rehydrate and access data. What is the purpose of defense in depth? The objective of defense in depth is to use several layers of protection to prevent information from being accessed or stolen by unauthorized users. What can you use to ensure that a user can only access applications from compliant devices? Conditional access is a tool that Azure AD uses to allow or deny access to resources based on identity signals, such as the device being used. SSO enables a user to sign in one time and use that credential to access multiple resources and applications from different providers. MFA is a process whereby a user is prompted during the sign-in process for an additional form of identification. Hybrid identity solutions create a common user identity for authentication and authorization to all resources, regardless of location. What can you use to allow a user to manage all the resources in a resource group? Azure ABAC allows you to assign a set of permissions to a user or group. Resource tags are used to locate and act on resources associated with specific workloads, environments, business units, and owners. Resource locks prevent the accidental change or deletion of a resource. Key Vault is a centralized cloud service for storing an application's secrets in a single, central location. Which type of strategy uses a series of mechanisms to slow the advancement of an attack that aims to gain unauthorized access to data? Which type of strategy uses a series of mechanisms to slow the advancement of an attack that aims to gain unauthorized access to data? A defense in-depth strategy uses a series of mechanisms to slow the advancement of an attack that aims to gain unauthorized access to data. The principle of least privilege means restricting access to information to only the level that users need to perform their work. A DOS attack attempts to overwhelm and exhaust an application's resources. The perimeter layer is about protecting an organization's resources from network-based attacks. What Azure AD feature can you use to ensure that users can only access Microsoft Office 365 applications from approved client applications? What Azure AD feature can you use to ensure that users can only access Microsoft Office 365 applications from approved client applications? What Azure AD feature can you use to ensure that users can only access Microsoft Office 365 applications from approved client applications? Conditional access allows administrators to control, allow, or deny access to resources based on certain signals. You can require that access to certain applications only be allowed if the users are using an approved client application. MFA is a process whereby a user is prompted during the sign-in process for an additional form of identification. Examples include a code on their mobile phone or a fingerprint scan. What can you use to ensure that users authenticate by using multi-factor authentication, MFA, when they attempt to sign in from a specific location? What can you use to ensure that users authenticate by using multi-factor authentication, MFA, when they attempt to sign in from a specific location? Conditional access can use signals to determine information about authentication attempts, and then determine whether to block access or require additional verifications, such as MFA. What are two characteristics of the public cloud deployment model? Each correct answer presents a complete solution. In a public cloud, services are offered over the internet and are available to anyone who wants to purchase them. A private cloud is limited to a single organization. Cloud resources, such as servers and storage, are owned and operated by a third-party cloud service provider and delivered over the internet. A private cloud consists of computing resources used exclusively by users from one business or organization. Which two characteristics are common advantages of cloud computing? Each correct answer presents a complete solution. Cloud-based apps can provide a continuous user experience with no apparent downtime, even when things go wrong. You can deploy apps and data to regional data centers around the globe, thereby ensuring that your customers always have the best performance in their region. Apps in cloud computing can scale vertically and horizontally. In a public cloud model, you do not get physical access to servers, as they are managed by the cloud provider. Why is cloud computing often less expensive than on-premises data centers? Each correct answer presents a complete solution. Why is cloud computing often less expensive than on-premises data centers? Each correct answer presents a complete solution. Renting compute and storage services and being billed for only what you use often lowers operating expenses. Depending on the service and the type of network bandwidth, charges can be incurred. Cloud service offerings often provide functionality that can be difficult or cost prohibitive to deploy on premises, especially for smaller organizations. Major cloud providers offer services around the world, making it easy and relatively inexpensive to deploy services close to where your users reside. Select the answer that correctly completes the sentence. Answer choice refers to upfront costs incurred one time, such as hardware purchases. Capital expenditures are one-time expenses that can be deducted over time. Operational expenditures are billed as you use services and do not have upfront costs. Select the answer that correctly completes the sentence. Increasing compute capacity for an app by adding RAM or CPUs to a virtual machine is called answer choice. You scale vertically to increase compute capacity by adding RAM or CPUs to a virtual machine. Scaling horizontally increases compute capacity by adding instances of resources, such as adding virtual machines to the configuration. Disaster recovery keeps data and other assets safe in the event of a disaster. High availability minimizes downtime when things go wrong. What are cloud-based backup services, data replication, and geo-distribution features of? What are cloud-based backup services, data replication, and geo-distribution features of? Disaster recovery uses services, such as cloud-based backup, data replication, and geo-distribution, to keep data and code safe in the event of a disaster. What is high availability in a public cloud environment dependent on? Different services have different SLAs. Sometimes different tiers of the same service will offer different SLAs, which can increase or decrease the promised availability. Select the answer that correctly completes the sentence. An example of answer choice is automatically scaling an application to ensure that the application has the resources needed to meet customer demands. Elasticity refers to the ability to scale resources as needed, such as during business hours, to ensure that an application can keep up with demand, and then reducing the available resources during off-peak hours. Agility refers to the ability to deploy new applications and services quickly. High availability refers to the ability to ensure that a service or application remains available in the event of a failure. Geo-distribution makes a service or application available in multiple geographic locations that are typically close to your users. Increasing the capacity of an application by adding additional virtual machine is called answer choice. Scaling horizontally increases compute capacity by adding instances of resources, such as adding virtual machines to the configuration. You scale vertically to increase compute capacity by adding RAM or CPUs to a virtual machine. Agility refers to the ability to deploy new applications and services quickly. High availability minimizes downtime when things go wrong. Which cloud service model provides you with the most control over the hardware that runs applications? IaaS is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs applications. Users do not control the operating system and do not configure the underlying servers in PaaS. With SaaS, you are using as is software hosted in the cloud, instead of creating a platform to host a software yourself. In a platform as a service, PaaS, model, which two components are the responsibility of the cloud service provider. Each correct answer presents a complete solution. In PaaS, the cloud provider is responsible for the operating system, physical data center, physical hosts, and physical network. In PaaS, the customer is responsible for accounts and identities. Which type of cloud service model is typically licensed through a monthly or annual subscription? SaaS is software that is centrally hosted and managed for you and your users or customers. Usually, one version of the application is used for all customers, and it is licensed through a monthly or annual subscription. PaaS and IaaS use a consumption-based model, so you only pay for what you use. What is the customer responsible for in a software as a service, SaaS, model? SaaS allows you to pay to use an existing application on hardware managed by a third party. You supply data and configure access. Customers are only responsible for storage in a private cloud. Customers are responsible for virtual machines and runtime in IaaS and the private cloud. Which cloud service model is used by Azure SQL database?
Hey everyone, so welcome to this AZ900 Azure Fundamentals Study Cram Reloaded, or the 2022 version. So this is an update to the study cram I posted back in June 2020 that's had about 150,000 views, and I just finished creating an entire AZ900 study course. This is 8.5 hours of complete training. So this was the original study cram that this is replacing, and then there's the course that I just posted a few days ago. It's 8.5 hours, it's every single skill that's assessed, and there is a download of the complete handout. So that download has all of the different links for the different pieces of information. It has the whiteboards of all those detailed lessons. And so that I would recommend you go and watch. So the idea is go through that complete course. It's 8.5 hours of your life, but it will put you in a great position. And then watch this maybe a few hours before the course. Maybe watch it a couple of times just to refresh and get those ideas back in your brain. As always, this is useful. Please do go ahead, like, subscribe, comment, and share. And you can hit the bell icon to get notified of new updates. So this is the cram for the AZ900 exam. So that AZ900 exam is what's going to go ahead and get you that Azure Fundamentals certification. So we can go to the AZ900 site, and it talks about what's kind of covered in the exam and the fact that it's going to get you that Azure Fundamentals certification. What's great about this page is, well, yes, you can go and schedule the exam, but it has the skills measured document. So you can download this document, and what it's going to do is walk through every single skill that is going to be assessed. So ideally, you want to be able to download this document and tick off each of those individual things to feel confident, yes, I'm ready, I know all of these things that I'm going to get tested on. And this is the structure of that 8.5 hour course. There's basically a lesson per each of these skills assessed. Then there's actually a link to the Microsoft Learning Path. So yes, I've created that full YouTube course, but I recommend you do this as well. It's a great course. Obviously, it's text-based. There's a few little videos sprinkled in, but it does have some exercises you can perform as well. So if you have the time, definitely would recommend you get to go through that as well to really just put yourself in as good a position as possible. The more resources you can get, the better position you're going to be in. So with that said, let's kind of jump over and really just start cramming. So we think about the cloud. Azure is a cloud service, and we use this term, the cloud. So really, when we think about a cloud, what are we really talking about? So understand what are the key principles and features we expect from a cloud. We expect to see agility. So agility in terms of, there's lots of different requirements we have, there's lots of different types of service. So I want to be able to use the right service that meets my exact goal. My needs might evolve, so I want to be able to change what I'm doing as my needs change. I don't want to be stuck with a certain technology, but also my usage amount is going to fluctuate over time. So agility is all about types of service and amount of service. And that really leads into this idea of kind of consumption-based. I want to pay for what I'm actually using at any given second. Because again, that agility, there's seasonality. The amount of work may vary by hour or day or week or year, month, maybe multiple years. So I want to be able to handle that by only paying for what I need at any moment in time. We think about high availability, HA. I want to make sure that, yes, the basic infrastructure that my service is running on is resilient to certain types of failure, but there's also mechanisms in place to help me architect my services to have high availability. Maybe distributing them over different racks, maybe distributing them over different data centers in a small area, maybe spread over data centers with hundreds of miles between them. We also think about disaster recovery, which builds into that high availability, but this time we definitely want that big distance. I want big distances, hundreds of miles, so if there was some natural disaster, it's not going to impact all of our deployments. And that agility, I talked about scalability. I don't want to worry about running out. I don't want these little islands of resource that, oh, this island could run out. When we think about the cloud, we think about pooling resources together, so this massive amount available to me, so there's always enough resource to meet my needs. Now, when I think about a cloud, so this is just thinking, okay, these are the definitions of a cloud. There's different types of cloud. We often think about, hey, yeah, the public cloud, but that's not the only type. Now, obviously, there is public cloud. So I have the idea of a public cloud, e.g. Azure. Azure is an example of a public cloud. And when I think about a public cloud, this is typically externally hosted by some provider. It's going to be multi-tenant, i.e. it's not typically infrastructure dedicated to me. I might access it over the internet. Now, it doesn't have to be exclusively over the internet. There are certain ways I can get private connectivity. It could be a VPN, could be a private connection, but typically and by default, it's going to be internet facing. These are very much going to have the idea of being consumption-based. I expect to pay for what I'm using. That's going to be a key tenet of that. And I think about many locations. I'm going to be able to pick, well, hey, yes, it's the cloud, but we still have to understand geography, so I can be maybe close to certain customers, because that latency thing, the time things take, can be a big impact, and I want to distribute things around. When I think about Azure, for example, well, there's this huge number of regions. So this is kind of an infrastructure map that we actually have available on the Azure website. If I skip the intro and just explore the globe, what we can see is there's just a huge number of regions available. Actually, make it 2D to make it quicker. All these little blue dots, these are regions. These are all distinct sets of infrastructure where capacity is available all over the world, so I can go and create resources there. So there's just a massive amount of these available to me. So that's the public cloud, but realize I can also have private cloud. Now, really, what is a cloud? Take everything else away, really what we're talking about is capacity. There's some capacity that exposes a certain set of resources that I can consume. And there's going to be certain APIs and interfaces to actually use that. Well, likewise, I can have capacity on premises. It could expose certain resources like VMs or containers, and I have certain management infrastructure to maybe facilitate the idea of a cloud, pooling things, user self-service, show back, charge back, all of those types of things. So here I could have a private cloud that's basically running on my infrastructure. So it's on premises. I might be able to do quotas and policies to help control, but I'm using my on-premises infrastructure. So that's private cloud. And then we have the idea of hybrid cloud. So as you would expect with hybrid cloud, it's essentially both of them. Maybe I'm using private cloud on premises to host some work. Maybe I'm using public cloud for other types of work. Maybe I run it on premises, but in busy times, that variable load, I burst out and start using the cloud. All of those things are available to me. So I have these different types of cloud, but absolutely Azure is an example of a public cloud. Now with that, there's things like operational expenditure, capital expenditure. And so those are all about how we pay for things. So I can often think about anything on premises, that's typically going to be CapEx, capital expenditure, i.e. I have to kind of pay for it up front. I buy my server, I buy my license, I buy my data center, and then depreciate it over a certain period of time. So I have these assets that has a certain lifespan. And the challenge with that is we have to do all that investment up front, so that can be fairly painful. I can compare that to the public cloud, but it's going to be OpEx, operational expenditure. I pay for it as I use it, which this OpEx really plays into that consumption-based nature of the public cloud. I pay for what I use. There isn't this big upfront cost. I pay for it as I use it. And that's really powerful because with CapEx, again, I get certain assets and I have to use. I have to use them for a certain period of time to get my value for money, and I lack a certain amount of flexibility. Whereas when it's OpEx and I pay for what I use, I can change my mind. I can start using a certain type of resource and then say, actually, that's not the right one for me anymore. Delete it, create a new type. I don't lose any money. I change for what I'm doing. If I'm using less, I pay less. If I'm using more, I pay more. So if I think of any type of workload where there's some variable load, typically the public cloud will be very uniquely suited for this to work. For example, you think about scenarios where maybe it's the idea that it's on and off. Maybe I'm a tax company and I only run for a few months a year. Maybe I'm a startup company and I'm growing really fast. Well, do I want to go and pay for all that hardware up front when I may fail? No. Maybe I just have these idea of variable loads and I just want to pay for what I'm using. So there's all these different scenarios where this consumption-based nature really is key for this to be successful. So let's focus on this idea of the public cloud. Now, one of the big focuses we have around the public cloud is this idea of shared responsibilities. That both the customer, i.e. me using Azure, and the provider, Microsoft, they have certain responsibilities for different aspects of the service. Now, that responsibility will change depending on which service I'm using. We often think about there's different layers to a complete solution. I can think, sure, there's things like storage, there's network, there's the servers, the compute itself, there's some type of hypervisor that basically creates VMs I can use. Then inside that VM, there's an operating system. There's a runtime like .NET or J2E. Then I get my app and then my data. And realize that as a business, the things we really care about is the app and the data. That's what sets us apart from other companies. So that's where we really want to be able to focus. So when I think about those layers that are what we care about, if we think on premises, well, we're responsible for all of that. So here, the customer is responsible for all of the layers. You may have different teams, but ultimately, it's all you as the customer. When you start to move to the cloud, you typically start with IaaS, infrastructure as a service. With infrastructure as a service, I can really think about this line there. So now the hypervisor, all of the fabric, the server, the network, the storage, well, with IaaS, the responsibility is, let's just say Azure. Microsoft, as the provider, are responsible for all of those things. You get a service offered to you, you don't manage any of that. What you get as the customer is for what is inside that virtual machine. So that includes things like, hey, I can pick the operating system. Is that Windows? Is that Linux? But then there's all the responsibilities for that. Okay, responsibilities for that means I'm worrying about things like, okay, patching it, the backup, config, antivirus, firewall. The list kind of goes on. There's all these responsibilities that I have, but I have full access to the operating system, so I have all of that flexibility. So in this world, with IaaS, we're really talking about kind of virtual machines and kind of virtual machine scale sets, which we're going to come back to more detail of what those services are. But for those, hey, I have full access to the operating system, so I have the most flexibility, but I have all the responsibility as well. Then we get to platform as a service, PaaS. So here the line of responsibility shifts all the way to there. So now Azure is responsible for basically everything. There's still an operating system. There's still runtimes, all those things happening. I'm not responsible for that. I may not even see it depending on the type of service. What I'm responsible for is my app and my data. So obviously, if I'm creating a custom service, I'd rather use this as my company. What differentiates me is my app and my data. I don't really want to be in the business of managing VMs and worrying about backup and patching and all of that stuff. So if I can, we like this idea of PaaS. And you'll hear services like Azure Container Instances, Azure Kubernetes Services, App Services. You'll hear about things like functions and Logic Apps, serverless offerings. And again, we're going to come back to all of these, but these are PaaS offerings. And then finally, I'm just in a different color, you have software as a service. The whole point of PaaS is it's providing these blocks. I can just focus on my app and my data, and this is what provides the business function. The PaaS service on its own does not provide a business function. With SaaS, it's providing that business function. For example, this could be Microsoft 365. It's providing me SharePoint. It's providing me collaboration. It's providing me mail, whatever that might be. It's all provided. I don't have any responsibility for the platform itself. I might do little things like administer users to enable them for a feature, but I'm not patching Exchange or patching SharePoint. There's Dynamics 365. There's all different types of SaaS. There's third-party SaaS solutions, but I am not managing over those. And again, just the key point here is I kind of want to get as far that way as I can because I don't want responsibility if I can get away from it. Okay, so let's dive into really what we think about. When we think about Azure, a big focus is on kind of IaaS and PaaS. And there's a kind of a joke. There's no such thing as the cloud. It's just someone else's PC. And there's an element of truth to that. If we think about that idea of capacity, well, I need capacity. I need compute, some servers. I need network switches to connect things together. I need some storage. So it has to live in some physical space. I talked about regions already, that flexibility to have many locations. And so a region is really one of the key building blocks when we think about Azure. So let's explore regions. So I can really think about the idea of Azure has many, many regions. I showed them already. And I can think about a specific region is East US or West US. And it's made up of multiple physical locations. So I could think about, okay, well, I have a region here. Within that region, there's multiple physical buildings. Now, what really defines the region is those buildings are all fairly close together. We talk about the idea of this 2-millisecond latency envelope. Don't worry about that too much. It's basically the longest amount of time something can take from the region to the edge of the region to talk, i.e. they're very close together. So I might have a region like East US, and then there's lots and lots of other regions. This could be a completely different region that would have its own buildings. That might be West US, for example. So we have all of these different regions. And the reason we have different regions is, well, there might be certain data sovereignty requirements. I might be in a certain country that requires me to have my data, remember, my app, in the same country. So there's requirements to host the data. So by having lots and lots of different regions, hey, I can stand up my services in a region in my country to meet data sovereignty requirements. Also, I want multiple regions so I can have DR. I want maybe hundreds of miles between them so that if there was some natural disaster, it's not going to impact my other service. Also, yes, a latency is the boundary of a region, but I might have customers all throughout the world. From the customer to the region takes time. So I want to be able to put my services all throughout the world maybe, so there's an instance close to my customers, so they get a really nice experience when using the service. Now, I'm talking about Azure and regions in Azure. The reality is there's actually more than one Azure environment. There are several. What we typically think about is kind of the commercial, like the regular Azure commercial that we all have access to. That's kind of how we think about it typically. But there's actually multiple regions. It's not just that commercial region. And we can see this. So if I jump over for a second and we go and look at a command prompt. So if I just jump over to this makes it a bit bigger for you. I can actually do a get AZ environment. And notice what we see. We actually see there's Azure cloud, kind of that regular commercial cloud. Then there's also a China cloud and an Azure US government cloud. Now, there is also an Azure German cloud, but that's actually getting a lot less investment now because of changes to regulations, changes to just regular regions. We're not going to typically see that used as much. But certainly we can think about, well, there's this China cloud and this US gov cloud. So why are there these separate regions? And it's really about compliance and certain regulatory requirements that I need to meet. So yes, we have commercial, which has a set of regions, but then there's also China. Now, China has requirements that it has to be operated by a Chinese company. So the China environment is actually operated by 21 VNet, and they basically license the Azure technology. So it has its own sets of regions. And then obviously we have kind of the US Gov, which has its own sets of regions. So they each have their different sets of regions. US Gov, for example, has a whole bunch of other regulatory standards that it meets. For example, CGIS, ITAR, there's a whole bunch of these available for it. But the idea is if I'm a company, maybe a government entity, hey, I have certain additional requirements that are not met by the commercial environment, well, I would use the US Gov. If I'm a Chinese company and I want my services hosted in China, I would use the China environment, which again has its own regions, has its own Azure AD, as does US Gov. So these are all essentially completely separated. They're different physical facilities, they're different logically, they're different networks, different identity providers. They are really isolated environments to meet whatever regulatory requirements that I may have for my particular workloads. And even when we look at the regions, you'll notice, well, some of them are particular environments. So we have this idea, we have multiple regions for those different reasons. I want DR capabilities to have a big distance between them. Regulatory, hey, I need the region in the same country I am. Hey, I want it close to my customers. So these are all super important. And that idea of disaster recovery is actually a key concept. So there are pairings in Azure. So certain regions are paired. And we can actually go and look at these pairings. And what we can see is this is showing us all of the pairings that exist. Now, what you're going to see here is that the pairings are in the same geopolitical boundary. For example, Asia replicates to Asia, Australia to Australia, Canada to Canada. The only exception is Brazil South currently goes to South Central US. This is because Brazil only had one region, so it had to replicate outside of Brazil. But South Central US does not replicate to Brazil. If you go and look, you'll kind of see South Central actually replicates to North Central US. Kind of see those there. So nothing ever replicates outside of the US from that capacity. You also see you've got like the US government regions here, US Gov Arizona, Iowa, and you can also see those China regions as well. So we actually see those different environments as well, which all have, so not Canada, they all have their own regions. So those pairings are used by certain services. So there are certain services in Azure like storage and Key Vault that use those pairings just behind the scenes. So that's how it does that resiliency. Additionally, those pairings are useful if I was deploying my own services, when Azure rolls out updates, it will not roll them out to paired regions at the same time. Imagine they introduced a problem with a software update, or you don't want to take down the primary and the DR region with the same update. So it's going to stagger those updates as well. So I can think about a region as a really big blast zone. If there was a problem, it shouldn't impact other regions. However, even within a region, as we saw, there's multiple physical buildings. And what happens in many regions is those physical buildings, well, they have independent power, cooling, and networking, i.e. communications. So they're independent. So these are then exposed as availability zones. Now there's more than 3 buildings. You can think about there's lots of other buildings sitting in that region, for example. And I can now think that, okay, great. I could now put my services distributed over multiple buildings. So now I have resiliency if an entire building has a problem by distributing my services over multiple buildings. The way this is exposed is we're going to have something called a subscription. And for each region, if it supports availability zones, you'll actually see 3 availability zones. You'll see an AZ1, an AZ2, and an AZ3. Now, that may map like that for that subscription. If I had a second subscription for the same region, it will also see 3 availability zones, but they might map to completely different buildings. My AZ1 could be that building, my AZ2 could be that building, my AZ3 could be that one. So there's no consistency between different subscriptions. The whole point of this is isolation. Within my subscription, yes, AZ1 will always be the same building, AZ2 will always be the same one, but there's no consistency between different subscriptions. When I think about services, services use these in different ways. For example, some services you will see are zone redundant. If it's zone redundant, it spans the availability zones just as part of the service. So it's automatically just redundant. There's nothing I have to do. Other services will be zonal. If it's zonal, it gets created in a specific availability zone. So I tell it the availability zone, and it will go to that availability zone. But to get resiliency, I need to create another instance in a different AZ, because the whole point is I want to be distributed over multiple buildings. So some services, it's just native. I can say, hey, I want to be zone redundant, and it will make it resilient. Others have to get pinned to a particular zone, and then I need to create multiple instances to get that protection if something happened to a building, like a VM. A VM cannot span availability zones. A VM can't exist in multiple buildings. So I'd have to create zonal VMs, and I'd create maybe 3. One in AZ1, one in AZ2, one in AZ3, to all provide the same service. We can see this. So if we jump over, if I actually go and look at a certain type of resource, for example, if I were to look at a public IP address, when we create a public IP, we actually get the choice. So I can say down here at the bottom, availability zone, and it's letting me pick. The default is zone redundant, but also I could say, actually, I want to make it zonal, put it in AZ2. So for some services, you'll get the choice. Other services, you won't. Other services have no ability to span multiple availability zones, like a virtual machine. It understands availability zones, so I can say here, use an AZ, but there's no option to be zone redundant. All I can say is pick which AZ I actually want to create it in because of the type of resource. So it's really important to understand kind of those concepts. And the key point here really is that I'll pick the one that makes the sense for what I'm trying to achieve. So if I think about, how do I use these? If you see a question and it's, hey, I need to deploy a service and I want to make sure my service can survive the failure of a data center, ping, availability zone. That's the answer. If you don't have that option, remember, I'd have the same protection if I use multiple regions, because obviously they're different data centers as well. But that's typically a very different architecture that would tend to be more DR purposes because of how we can synchronize data. So if it's, hey, within a region, I need protection from a data center failing, do I use a availability set, availability zone, or a resource group, or any of those things? Hey, availability zone is a distinct physical building with isolated power cooling networking. It helps me by deploying my services over AZs from any particular failure. So that's kind of a key point. So the regions and the availability zones, they're physical constructs. Then we get these logical components of resources we want to use. So the first kind of building block we're actually going to see is identity. So we'll often hear about Azure AD. So I'm going to draw Azure Active Directory. And you may just hear it called AAD. So Azure AD is a cloud IDP, an identity provider. It's used by Azure and many, many other types of service. Within there, I have things like users, I have groups, I can have devices, I can have applications defined. I have all these various things in my Azure AD. And it speaks cloud. What do I mean by that? There's different types of protocols, different types of authentication, authorization. So it speaks things like, hey, OpenID Connect, SAML, WSFed, OAuth2. They're all things we typically think about for the cloud and how things can work together. Now, I talked about authentication and authorization. So what am I really talking about? So authentication, and I can really break some of these down. So we typically think about these around authentication. Authentication is all about proving who I am. That's what authentication is about. You may see it written as auth-n. So who am I? I want to prove I am who I say I am, or an app or service principal is. Typically, we prove that by a number of ways. Something I know. Something I know is typically like a password or a PIN. It might be something I have. It could be a token, some sort of device that I can put in, or maybe it's a time base that shows a code. It could be my PC. It could be my phone. Or it's something I am, i.e. a biometric. Fingerprint, 3D face scan, smiling at the thing. So I want to prove who I am by one of those kind of things. And what we like in authentication today is the idea of MFA, multi-factor authentication, i.e. 2+ of these. And I want just one of them, I want at least 2 of them. Hey, maybe it's something I have, my PC, and then a PIN for that PC. That'll be multi-factor authentication. Maybe it's going to be a code from my phone. Well, the code from my phone, I have the phone, and then it's maybe unlocked with my biometric. So I want multi-factor authentication to get that really strong authentication, give me more confidence I really am who I say I am. You'll hear about things like Hello for Business. That uses your PC and a trusted platform module chip inside the PC, and then you unlock it with maybe a biometric or a PIN, and it's something I have, the PC, so with that unlock, it's MFA. Now, MFA is available to all users of Azure AD if I turn on security defaults. I don't get to configure very granularly how that's going to work, but I can get it for everyone for certain actions. If I have Azure AD Premium, then I can control the multi-factor authentication through things like conditional access, which we're going to talk about. Global administrators always get the full kind of MFA set capabilities, and Office 365 users get a subset of MFA for the Office 365 apps. So authentication is who I am. Then we talk about, well, authorization. So authorization is really about what, trying to write too fast, what I can do. So I've proved who I am with authentication. Now, once I'm authenticated, it knows who I am. Authorization says what I can do. And often we'll hear about things like role-based access control as a whole part of controlling, well, what exactly can I do? Now, I talked about with Azure AD, we like this idea of conditional access, which can really feed in to, like, do I require MFA if I have that premium P1 or premium P2 license? And it's a big part of, hey, driving some of that authorization. So I can think about conditional access kind of sitting as that gateway anytime I ask Azure AD for a token, which is how we actually go and communicate to other things. So what I can do with conditional access is based on certain conditions, I can have requirements. So I specify conditions, and I add requirements. For example, hey, you need to MFA. You have to be on a trusted device. You have to be hybrid Azure AD joined. And if we super quickly just jump over, if we go and look at Azure Active Directory, and we look at security, and on security look at conditional access, we can create policies, and we can see, hey, look, we have assignments. We can assign it to certain users and groups or certain roles. I can target certain cloud applications. So any application that trusts Azure AD could be targeted with its own policy. I can add lots of different conditions. The user's risk, the sign-in risk, the platform they're using, what location they're coming from, device state. And I can have different controls. Hey, look, I require multi-factor authentication, or I require it to be marked as compliant, or it has to be Azure Hybrid AD joined. And I can pick, well, do I require all of those things, or do I just require one of them to be true? So I have a lot of control around that. So conditional access is all about, as the name suggests, giving me very granular control about when a certain application should be available, and then what needs to be met to make it available. And that's kind of a key point. We have this Azure AD, this cloud identity provider, and the whole point of this is we have all these different cloud applications that will trust Azure AD for that authentication authorization. Obviously, Azure is an obvious one. So it's going to trust a particular Azure AD tenant. I have an instance of Azure AD as a tenant for my company, but also so does things like Microsoft 365. So do thousands and thousands of other third-party cloud applications. You can all use Azure AD. And so what that's going to give me is this ability to give a great experience for the end users, because instead of having a different identity at every single cloud application, which could be hundreds, which will be a disaster, I can have one identity. Now, most of the time what will happen is a company already probably has an Active Directory. This is an on-premises directory system, Active Directory domain services. And they already have users in here and groups in here and maybe other things. So what will happen for most companies is you're actually going to synchronize using something called Azure AD Connect. So this is going to take the users and the groups and synchronize them up into Azure AD. So my user here also has an account up here. And it does a number of different things. Once I have that synchronization, what I can then turn on is SSO, seamless sign-on. What that means is, if I'm authenticated already, if I go and access one of these cloud applications, I'm not going to get prompted to authenticate again. I already have the required authentication in place, so we can go and check, hey, conditional access for the authorization, and there's certain requirements I have to meet. I'm not going to get prompted to re-enter my password or maybe MFA again if I've already got a strong authentication. I'll just seamlessly be able to access those. So I'll authenticate maybe once at the start of the day, and then I'm good. It's not going to keep prompting me over and over again. So this is all of the idea that, hey, Azure AD becomes this central identity provider, not just for Azure, but for thousands and thousands of other applications out there. Now, this is great.
Which two factors affect Azure costs? Each correct answer presents a complete solution. Which two scenarios are common billing use cases for resource tags? Each correct answer presents a complete solution. You plan to build a new solution in Azure that will use Platform as a Service, PaaS, products. What should you use to estimate the monthly costs? Which two features are available by using Azure Cost Management and Billing? Each correct answer presents a complete solution. Azure Cost Management allows you to create and manage cost and usage budgets by monitoring resource demand trends, consumption rates, and cost patterns. It also allows you to use historical data to generate reports and forecast future usage and expenditures. What can you use to ensure that new and existing Azure resources stay in compliance with corporate standards? You need to identify which Azure services are compliant with ISO 27001 Information Security Management Standards. Where should you go to locate the information? The Trust Center showcases the Microsoft principles for maintaining data integrity in the cloud and how Microsoft implements and supports security, privacy, compliance, and transparency in all Microsoft Cloud products and services. You need to ensure that multi-factor authentication, MFA, is enabled on accounts with right permissions in an Azure subscription. What should you implement? What can you use to ensure that a development team can only create virtual machines of a certain size? Azure Policy enables you to define both individual policies and groups of related policies called initiatives. Azure Policy evaluates your resources and highlights resources that are not compliant with the policies you created. Azure Policy can also prevent non-compliant resources from being created. Which management layer accepts requests from any Azure tool or API and enables you to create, update, and delete resources in an Azure account? ARM is the deployment and management service for Azure. It provides a management layer that enables you to create, update, and delete resources in an Azure account. What should you use to access Azure Cloud Shell? Which two tools can you use to create a new Azure virtual machine from a mobile device that runs Android? Each correct answer presents complete solution. The Azure portal can run on devices that have the Android operating system installed. The browser can be any type, such as Internet Explorer 11, Chrome, Firefox, or Safari, all the latest versions. When you visit the portal, you will see Cloud Shell. Users can then access Bash and PowerShell from within Cloud Shell. You can use Bash and PowerShell to create Azure virtual machines. What can you use to manage servers across cloud platforms and on-premises environments? What can you use to manage servers across cloud platforms and on-premises environments? Azure Arc simplifies governance and management by delivering a consistent multi-cloud and on-premises management platform. Azure Arc simplifies governance and management by delivering a consistent multi-cloud and on-premises management platform. You need to be notified when there are new recommendations for reducing Azure costs. Which tool should you use? Azure Advisor evaluates Azure resources and makes recommendations to help improve reliability, security, and performance, achieve operational excellence, and reduce costs. You need to create a custom solution that uses thresholds to trigger auto-scaling functionality to scale an app up or down to meet user demand. What should you include in the solution? Azure Monitor is a platform that collects metric and logging data, such as CPU percentages. The data can be used to trigger auto-scaling. What should you proactively review and act on to avoid service interruptions, such as service retirements and breaking changes? What should you proactively review and act on to avoid service interruptions, such as service retirements and breaking changes? Health advisories are issues that require that you take proactive action to avoid service interruptions, such as service retirements and breaking changes. Service issues are problems such as outages that require immediate actions. What can you use to automatically detect performance anomalies for web apps? What can you use to automatically detect performance anomalies for web apps? Application Insights is a feature of Azure Monitor that allows you to monitor running applications, automatically detect performance anomalies, and use built-in analytics tools to see what users do on an app. What can you use to find information about planned maintenance for Azure services that are critical to your organization? You can drill down to the affected services, regions, and details to show how an event will affect you and what you must do. Most of these events occur without any impact to you and will not be shown. In a rare case that a reboot is required, Service Health allows you to choose when to perform the maintenance to minimize the downtime. Which two attributes are characteristics of the private cloud deployment model? Each correct answer presents a complete solution. In a private cloud, hardware must be purchased for startup and maintenance. In a private cloud, organizations control resources and security. Quick provisioning is a characteristic of the public cloud deployment model. Paying only for what is used is a characteristic of the public cloud deployment model. What are two characteristics of the public cloud deployment model? Each correct answer presents a complete solution. What are two characteristics of a consumption-based model? Each correct answer presents a complete solution. What is an advantage of cloud computing compared to on-premises deployments? Increasing the capacity of an application by adding additional virtual machine is called answer choice. Which cloud service model provides you with the most control over the hardware that runs applications? Your organization is building a custom application. You need to focus on application development rather than configuration and management of servers. Which cloud service model should you use? With PaaS, users can focus on application development because the cloud provider handles all the platform management. In SaaS, the cloud provider manages all aspects of the application environment, such as virtual machines, networking resources, data storage, and applications. IaaS is the closest service model to managing physical servers. Which cloud service model is used by Microsoft Office 365? IaaS helps you reduce the cost and complexity of maintaining a physical server and its data center infrastructure. Virtual networks are part of the IaaS cloud service. Answer choice is the logical container used to combine and organize Azure resources. Resources are combined into resource groups, which act as a logical container into which Azure resources like web apps, databases, and storage accounts are deployed and managed. Answer choice are physically separate data centers within an Azure region. Availability zones are physically separate data centers within an Azure region. Each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. In a region pair, a region is paired with another region in the same answer choice. Each Azure region is always paired with another region within the same geography, such as US, Europe, or Asia, at least 300 miles away. For which resource does Azure generate separate billing reports and invoices by default? Azure generates separate billing reports and invoices for each subscription so that you can organize and manage costs. Resource groups can be used to group costs, but you will not receive a separate invoice for each resource group. Management groups are used to efficiently manage access, policies, and compliance for subscriptions. You can set up billing profiles to roll up subscriptions into invoice sections, but this requires customization. Which resource can you use to manage access, policies, and compliance across multiple subscriptions? Management groups can be used in environments that have multiple subscriptions to streamline the application of governance conditions. Resource groups can be used to organize Azure resources. Administrative units are used to delegate the administration of Azure AD resources, such as users and groups. Accounts are used to provide access to resources. Which Azure resource is a software emulation of a physical computer that includes a virtual processor, memory, storage, and networking resources. A VPN gateway is a type of virtual network gateway. Azure VPN gateway instances are deployed to a dedicated subnet of a virtual network. You can use them to connect on-premises data centers to virtual networks through a site-to-site (S2S) VPN connection. What can you use to connect Azure resources, such as Azure SQL databases, to an Azure virtual network? What can you use to connect Azure resources, such as Azure SQL databases, to an Azure virtual network? Service endpoints are used to expose Azure services to a virtual network, providing communication between the two. ExpressRoute is used to connect an on-premises network to Azure. NSGs allow you to configure inbound and outbound rules for virtual networks and virtual machines. Peering allows you to connect virtual networks together. Which two services can you use to establish network connectivity between an on-premises network and Azure resources? Each correct answer presents a complete solution. What can you use to provide Mac and Android users with access to a Windows environment that will run Windows-based applications? Which storage service offers fully managed file shares in the cloud that are accessible by using Server Message Block (SMB) protocol? Which Azure storage service should you use to store unstructured files, such as images, that will be served on web pages? Which two protocols are used to access Azure file shares? Each correct answer presents a complete solution. What enables a user to sign in one time and use that credential to access multiple resources and applications from different providers? What can you use to allow a user to manage all the resources in a resource group? Azure ABAC allows you to assign a set of permissions to a user or group. Resource tags are used to locate and act on resources associated with specific workloads, environments, business units, and owners. Resource locks prevent the accidental change or deletion of a resource. Key Vault is a centralized cloud service for storing an application's secrets in a single, central location. What Azure AD feature can you use to configure security authentication that requires users to use their mobile phone to sign in? Which two services are provided by Azure AD? Each correct answer presents a complete solution. Azure AD provides services for verifying identity and access to applications and resources. SSO enables you to remember a single username and password to access multiple applications and is available in Azure AD. What Azure AD feature can you use to ensure that users can only access Microsoft Office 365 applications from approved client applications?
This idea of the central Azure AD. We have identity in place. But there might be other requirements we have when we start creating resources. Hey, what regions we're allowed to create in, what types of service we're allowed to create, what types of replication we want. And if I think about the old days, if I think about this, the on-premises days, if I was a user and I wanted something, what would we do? Well, there was probably kind of an IT operations person, IT ops, and they had access to the servers where you could actually create stuff. So what would happen is I would put in a request. Hey, I want this thing, please. I want a VM or 10 VMs or a database. And the IT operations, well, what they would essentially be doing would be the checks. Okay, you put in this request, does it meet our requirements in terms of governance, in terms of regulatory, in terms of all these other things? And only if this passes, would they then go and actually create. So that IT operations person wasn't just a person that created things, they were the ones making sure our requirements for compliance and everything else were being met. So that was great. Well, that doesn't exist in the self-service world. If we take this same scenario, but now I think about the cloud, I think about Azure, for example, well, it's self-service. There is no IT operations person in the middle of that interaction. But I have the same requirements. The IT operations person would check, hey, we're creating the right things. It would then maybe give me the right sets of permissions. It would maybe enforce certain budgets. Hey, you're spending too much money. I'm not going to let you create these things. So those controls that used to be in place, those checks, I need to do another way. I still need those checks, but now I need Azure to do them. So let's think about, well, exactly what those checks could be. So we talked about, well, maybe they gave certain permissions. So a big one here would be role-based access control. The idea, remember, so if I think about all these things, this is what I can do. So role-based access control in Azure is all about the idea that we have various roles, and a role is just a set of actions. There's all these different resources in Azure that, depending on the type of resource, there's different actions you can perform. So we have roles. So then a role, maybe it's easier to just go and see one of these quick. So if we were to jump over, and I just went and looked at, for example, a virtual machine, I'll just pick one, and we can look at access control, and I can look at the roles that exist. Notice there's all these different roles. Now key ones are kind of owner, oh, that zoomed in a long way. Here's owner, contributor, reader. These are generic and available for pretty much everything. As the name suggests, owner is the owner of the resource. They can do anything, including change permissions. A reader can read anything, but can't change anything. A contributor can do pretty much any action except change permissions. So they're like the owner, but they can't change permissions. Then there's many other roles that are a subset. For example, here I can have a virtual machine contributor. And I can go and look at, well, here are all of the actions they can perform. So we can see a list of all of these different things based on the different types of resource. They can perform all these different actions. And so role-based access control is all about the idea that I have a certain role that I want to give to a certain identity. That could be a user, it could be a group, it could be a service principal, which represents an application at a certain scope. I'm going to talk about what those scopes are, but management group, subscription, resource group, resources themselves. And those things together are a role assignment. We can think about role-based access control is about giving a certain entity, a user, a group, a service principal, a certain set of permissions at a certain scope. So that's, hey, this is what you can do. So the next thing I care about is policy. So if RBAC is kind of about, okay, what I can do and who can do those things, policy is going to control maybe the where and the how I can do these things. So these are all about guardrails. If you think about that IT operations person may be controlled, you could create things in these locations of this type. That's exactly what a policy can do. So actually, I might change this. I might, to make this simpler for you to think about, maybe this is more about who can perform the action, and this is what they can perform. But realize the role also controls kind of what you can do. So if we go and look at a policy for a second, if I look at policy, there's a whole bunch of definitions, and you'll see a huge number of these. So many on all different categories of types of service. But we could unselect and only look, for example, at storage. And you'll see there's all these different definitions. And I could say, hey, storage accounts should use private links. Storage accounts should use customer managed keys. Storage accounts should be limited to allowed SKUs, i.e. control which types of storage accounts I can create. So I'm basically putting in all of these different controls. And what this can do is I can use these not only to stop or allow someone doing this, I might put it in an audit mode so they can do it, but it kind of tracks and I can use that for compliance. I might even use them to correct something if it was deployed incorrectly. So different ways I can use policies. And rather than having to deploy each of these one at a time, I can actually create initiatives. So initiatives are just groups of policies. And there are many built in. There are additional ones available for certain compliance requirements, like here you can see, hey, look, NIST SP800 Rev 4, that's 989 separate policies. And so then I can just assign this initiative at a certain scope. So that word scope again. But what's really nice is, again, I can use it to control, but I can also use it for compliance. I can quickly see for each policy or initiative, how am I actually doing in terms of that assignment and how am I meeting that in terms of my compliance? So I think about policy as about those guardrails. So yes, it can control. I can stop you, I can correct you, but I can also use it for audit purposes. I can see, well, what is my compliance? So there's different ways I can assign that, but it's those guardrails to help control. And again, I apply this at a certain scope. And then I think about budget. And maybe that's how much. I want to control how much of something you can create. Again, at a certain scope. And maybe that's, hey, I want to control how much you're going to spend based on what you've spent so far. Or maybe I'm going to look at trends and say, hey, look, if you carry on as you are, you're going to spend this amount. So I want to kind of stop you now or alert you now so we can kind of change track. for all of these different things, they're actually going to get inherited because we're going to be able to apply them at this scope word. So all of these apply at a certain scope. So what are those scopes? So we talked about, we had Azure, that's the cloud. And we talked about, well, what actually happens is that Azure cloud we have trusts a particular Azure AD tenant. So my Azure subscription is going to trust a certain instance of Azure AD. Under my Azure AD, we have something called a root management group. So what we're now talking about is this idea of management groups. And I can create a hierarchy of these. So I can create this whole hierarchy of management groups to fit my needs. This could be based on maybe dev, test, and production, different countries, different business units. They're there for my benefit to apply these things to. So management groups, RBAC, policy, and budget, at any of these levels can have these applied. And I could apply to all of them. We tend to be more loose and general at the top and get more specific as we get closer and closer to actual resources. But I can have up to 6 levels of management groups, not including the root, but they're designed around, hey, I want to apply RBAC, policy, and budget. And for everything we're going to see here, they are going to get inherited all the way down to everything we're going to do. So if I assign a policy at this management group, it will get inherited by this management group and this management group and then everything underneath as well. Same for RBAC, budgets would roll up to wherever I set it. So management groups are there to help me assign RBAC, policy, and budget, and for loose organizations. So if the management group is there to help me kind of structure and control those governance type features, where do we actually create stuff? So the next construct we have is the idea, well, under a certain management group, I create a subscription. And I can have lots of subscriptions. I might create different subscriptions, again, for different accounting, different business units, different purposes. Subscriptions do have limits. Now, they're pretty big, but we can go and look, and Azure Subscriptions and Service Limits page goes through all of the different limits that apply. See, some of these numbers are pretty big. So maybe I have to have certain different subscriptions just because I've maxed it out. I have so many things, I need to have a different subscription just because of that. That's not super common. What's more likely is I have different subscriptions for some kind of structural benefit for how I'm organizing, or I want certain isolation. Because a subscription is a base unit of Azure interaction. It's part of the agreement between the customer and Microsoft. It uses a certain billing model, like pay-as-you-go, maybe it's part of an enterprise agreement. It's kind of a billing boundary, is what it's really useful for. Well, all of those things, RBAC, policy, and budget, I can apply them to management groups. Yep, I can apply them here as well. So I can apply RBAC, policy, and budget here as well, which will also get the ones that will apply to management groups above it. So I have these different subscriptions. Now, once we have that, and I want to create something, well, when we create resources, resources get created in a resource group. A resource group exists in a specific subscription. I can have lots and lots of resource groups in a single subscription. I cannot nest them. And what can I do at a resource group? Hey, I can apply role-based access control, policy, and budget. You get the idea. Again, these all inherit down. So the resource group inherit ones from the subscription and the management groups all the way down. So it just gets more and more granular. So hey, this certain resource group has a certain app that needs a different policy, something more specific. Hey, I can do that, or a different set of role-based access control. I can do that there as well. Resource groups are not a boundary of use, though. What I mean by that is, for example, I might have in this resource group a virtual machine that's connected to a network interface card. Maybe this resource group over here has a virtual network. Well, I can still connect the NIC to that virtual network. So resource groups are not a boundary of any kind of connectivity. They're there partly for these role-based access control, policy, budget. But I really think about resource groups as things that have a common life cycle. What I mean by that is the things are going to get created together. They're going to run together. Ultimately, they're going to get deleted together. So I put them in a resource group as that boundary, really that coupling together. So it makes it very easy for me to understand. Because most likely, all the components in the same service, well, I probably want to have common role-based access control, or maybe common budgets. When I deploy and provision things, I'll push it into a resource group. So having that ability to have this common life cycle, that's really a key reason we would use resource groups. Think about how I finish with a certain project. Rather than trying to scour around 50 different places, oh, that project was in that resource group. I can just delete that resource group. And that's really the key point around there. Now, okay, so we have these key logical constructs: management groups, subscriptions, resource groups. I can apply those key governance constructs, role-based access control, policy, and budgets. Understand what those do. Role-based access control, well, who can do certain actions? Policy, what can I do? I can put guardrails and control that stuff. Budget, well, how much of that can I do? And all those things can be applied at these scopes to help, hey, I don't have to deploy the same policy in RBAC to 100 different subscriptions. Well, they can all roll up under certain hierarchy management groups and apply it at the management group. So it makes my life easier. Now, when I think about this, these are all inherited down, great. But how do I actually interact with this thing? So if I think about, well, there's Azure. There's actually a thing called the Azure Resource Manager, ARM. This is how I talk to Azure. So no matter what I'm doing, I'm actually going to talk to the Azure Resource Manager. Now, Azure itself is actually made up of, I talked about creating resources, a VM, a network interface card, all those things. So Azure is actually made up of resources that are defined in resource providers. So that tells me all of the different types of resource I can actually create. If we jump over and look, so if I clear this out for a second, if I do a get AZ resource provider, there's a lot of different resource providers in the system. And what we can see, for any of these particular ones, you can start to see, hey, look, there's resource types listed. But if we dive into one of them, we've got a particular provider namespace, Microsoft.compute, and I mean to capitalize that, and we can format it as a table and just look at resource types, we'll see there's just a whole list of different resource types existing in here. So this is just compute. Then you see obvious things you'd expect. Virtual machines. That's a particular resource. Virtual machine scale sets. Locations. Remember, are there different regions? But then we'll see other things. We'll see things like disks. Disks are part of compute. So there's all these different types of resources that actually exist within Azure. So the Azure Resource Manager is really what understands and facilitates that. And everything in Azure is a resource, even a VM. So we talk about a VM as that this really simple thing. Well, the reality is even a VM, that simple little virtual machine we might have, when I go and look at a virtual machine, what I can do is, well, hey, here's a VM, and I deploy it to its own resource group. So it's in a certain resource group. If we look at this resource group, it contains one VM. It actually contains 5 different resources. So what does it have? Well, it has the VM itself, but the VM connects to a network interface. The VM connects to a disk for its operating system. The network interface connects to a public IP address. And the NIC can use a network security group to control the flow of traffic. And there can be other resources as well. So everything is a distinct resource, but that's good. Because I didn't draw it on the picture, but I can also do RBAC at the resource level. I can go and see all the policies that apply at the resource level because they've all inherited down. And all of those things are available to me here. So the Azure Resource Manager provides that management for Azure. So when you hear ARM, you can think that the key point of all of this is management kind of interactions. And everything is going to use that. So if I think about me as a user, and I'm sitting at my machine, I have different ways of talking to Azure. The most common one we are typically going to start with is the portal. Well, the portal is talking to Azure. And I've kind of shown the portal already. Now, the portal is very pleasant. It's very intuitive. The portal is great to quickly look around. I can say, oh, okay, let's look at my resources. I can see my virtual machines. I can go and investigate this virtual machine. Oh, maybe I want to see some basic monitoring information about what's happening. It's great to quickly go and look around. It's good to do little investigations. It is not good to create things, to provision. Think about just creating a virtual machine. I have pages and pages of things that I would have to configure. So understand the pain point of that. Think about that for a second. If I was going to use the portal to provision resources, I'd have to make sure I did it in a consistent manner. So that's a super detailed document, and humans do kind of click the wrong things, and the portal might change. So some screenshot, or the button's slightly different. Try and create 100 of them. I'd be crying. So it doesn't scale. It's hard to document. It's hard to compare to a desired end state. There's just so many options. So the portal's great to go and look at things. I would never ever want to go and create things from the portal. But it's good to just kind of look around. Now there's also something called the Cloud Shell, which lets me get to things like PowerShell and Bash. If you looked at the portal for a second, up here in the corner, you'll see this little icon. So that opens up the Cloud Shell. So the Cloud Shell lets me run. So I'm about to show you PowerShell and the Azure CLI. It lets me run both of those so I can pick. But it gives me access without me having to install anything locally on my machine, a Bash environment for the Azure CLI, and a PowerShell to run the PowerShell. So that's just natively part of the portal. So that can be super convenient. There's also the mobile app. So this is available for kind of iOS and Android, sadly not Windows Phone. Once again, this talks to the Azure Resource Manager. The mobile app is great for, hey, I'm on the go. I want to quickly look at the state of my resources. Maybe look and see if there's certain alerts. I could start and stop things. I can access the Cloud Shell from there as well, so another useful thing. But once again, I'm not going to try and really do any big management from my mobile device. I'm not going to try and provision resources from that. So then we get to things. PowerShell AZ module. Now, PowerShell is open source. PowerShell is multi-platform, Windows, Linux, Mac OS, which means the AZ module is Windows, Linux, Mac OS. And this is phenomenal for automation. I just want to interact from a command line. So over here, for example, I've been using this already. You see me run certain commands. Hey, I want to go and see what VMs I have super quickly. Oh, git AZ VM. You can see I've got those commands. And obviously I can use that interactively, but that's also really powerful for automation scripts. I want to automate a set of management actions. These are phenomenal for automation. And likewise, if that's sort of PowerShell based, then there's the AZ CLI. That's more kind of a Bash kind of history. I can run it on Windows as well, CMD. And that has exactly the same capabilities. So I'm going to jump over to just a regular command prompt now instead. And what we can see here is, if I clear this quickly, make this a bit bigger for you, I can do an AZ VM list output table. I see the same information. It's a different syntax because it's more in the Bash world. But I can do the same exact type of things. It's just the syntax is different. So these are super, super powerful for a command line interface, scripting. I still don't want to create things with these. Although it's easier to create things with this, it's still not the right solution. But again, they go through the Azure Resource Manager. So far I've shown you the portal, there's a mobile app, there's PowerShell, there's the AZ CLI. We're not creating anything. So I keep saying don't create things with this. How we want to create things. There's ARM, JSON, templates. Everything in Azure, the metadata that describes it, is stored as JSON, JavaScript Object Notation. So what I can now do is I can apply a template to that Azure Resource Manager. And this is the way we want to do provisioning. And there's a reason for this. This is declarative. And what that means is, if I was to create something through PowerShell or AZ CLI, I have to tell it how to do something. New VM, add disk. Well, if the script failed halfway through, I wanted to change config, I can't just run the script again and change a value. I have to use completely different commands. So I'm telling it how to do it. It's imperative. This is what I want you to do. With declarative, I simply say, what is my desired end state? I could say, hey, I want a storage account called SA1, and I want it to be a locally redundant storage account. go and make it so. And it will go and look, well, does this exist already? Is it LRS? If not, I'll create it. But it's idempotent. I can run this as many times as I want. It's already created it, and it matches, it just won't do anything. Whereas if I run a script to create a storage account and it existed, it would error. But I can also change my mind. I say, actually, I now want this to be GRS. Make it so. And it would see, well, the storage account is there, but it's LRS. I'll change it to GRS to match that desired state. So this is kind of where this is so powerful. This is why we want to provision things with JSON templates. It's declarative. I say what I want. I don't say how to do it. So I can easily go and modify those things. And we can actually see, so behind the scenes, if we were to just go and look at really any type of resource, we look at my VM again, and it's going to look, honestly, kind of, there's a lot to it. It's not super friendly to actually understand. But you can do an export template, and it's actually going to show me the JSON. So here I can see, okay, yeah, it's a type Microsoft Compute Resource Provider of type virtual machine. Okay, then there's a name, which is a parameter, it's in a certain location, and there's a whole bunch of other configurations and properties for that. I can see the VM type, there's a whole bunch of stuff here, but it's declarative. I could run this as many times as I want, and it will just make it so. So this is the preferred way to provision things, an ARM JSON template. It has massive parallelism. It could create 100 resources, and it would create them all in parallel. We wouldn't wait for resource 1, then resource 2, then resource 3, so it's super powerful from that perspective. And what's really useful is it's a file, so I can compare it to what's actually there. But if we think about things like DevOps, I could absolutely have some kind of GitHub repo or Azure DevOps repos or whatever it is, something probably Git-based. I can store that in there, well, then I get things like version control. I get great collaboration features. So the fact that this is declarative file makes it really good to actually then work with other things. I can have parameter files, so I can have different values for different environments, but I can now use this file across many, many different types of things. And I can define anything in there. Role-based access control, policy, all those can be defined as that Azure JSON template. Now, what you may also hear about is a technology called Bicep. So Bicep is something new, and it actually transpiles, which means it converts into an ARM JSON template. But this is just more human-friendly. So I think in the future, you're going to see more and more Bicep as a friendlier way for us as a human. I want to create this declarative template. Instead of having to try and write JSON, which is really kind of ugly, I could write this really nice Bicep file. I've got an example here of a Bicep file. So this is creating a storage account. And what you can basically just see is I've got a few parameters. I'm saying I want to create a resource of type storage account. And it has a name, location, kind, and SKU. And that's it. So that's me as a human typing that out, which is actually really, really nice compared to the pretty hideous world of trying to actually create an ARM template. So you may hear the term Bicep, but it's just going to go and create an ARM JSON template behind the scenes. There are third-party solutions like Terraform. Terraform's great. Maybe I'm using more than just Azure. I think I've got AWS and Google Cloud. I've got maybe VMware and Kubernetes. I want one declarative technology for all of those. Well, Terraform will let me do that. So we talked about governance things. There are some other types of governance constructs. So if I think about this for a second, RBAC is great. RBAC controls what I can do. But maybe sometimes I want an extra check.